What you're looking at is one modular system running on 4 completely different characters. No character-specific spaghetti code, and no complicated setup for each one. This is the Advanced Weapons System. It's designed to be a drop-in component, allowing you to manage your entire arsenal through data, not a mess of nodes inside your character blueprint. In this video, I'm going to show you exactly how to set this up from scratch. We'll go over the data table architecture, creating your data assets, and getting the component talking to your animation blueprint. We're keeping it simple and fast. By the time we're done, you'll have a professional, data-driven framework ready for your project. Let's get started. First, we'll enable the plugin and set up our workspace. Organization is key in larger projects, so we'll create a _game folder and a data subfolder. We're creating a data table using the ws_weapon system row structure. This table is the brain of your game. Let's add our first row, unarmed. This is a critical step. Notice the inventory slot. You need to number these slots carefully. 0, 1, 2, and so on. This index is how the system identifies which weapon to pull when you press a key later. I'll go through the setup for a pistol. We add a new row to the data table and change the inventory slot to 2. We add a weapon sight if we have one. Add the skeletal mesh that we'll actually be holding and static mesh that will be for the pickup. We add the firing and reload sounds, the muzzle flash, and impact effect if they are not set up in the montages. We also have the option of using camera shakes and recoil if so desired. Look at the variables here. We've included everything. You can define if a weapon uses a specific projectile blueprint, its fire rate, and even the sockets it should attach to on your character mesh. We've even included a support hand socket for those two-handed rifles to ensure the left hand follows the weapon correctly. If you're building a shotgun, you can set the pellet count and spread angle right here. The system handles the math, multiplying your base damage by the pellet count automatically. For archery, we have specific toggles like no reload for persistent arrows and overdraw bonuses. Once the table is set, we create our data assets for the animation instance. This is where you link your montages: equip, aim, fire, and reload. By separating animations into data assets, you can change a character's vibe just by swapping a file, without touching the code. Duplicate your data assets for each weapon type you are using, and add the respective montages you have for those weapons. Once the table is set, we create our data assets for the animation instance. This is where you link your montages: equip, aim, fire, reload, and death if you are not using ragdoll physics. By separating animations into data assets, you can change a character's vibe just by swapping a file, without touching the code. Or if you are using multiple characters, you can add the data assets that control that character's montages without having to create a new data table. You would just need to add a tag to that character and add the skeleton to the data table so it finds it. Now, let's open the character blueprint. This is where we wire the brain to the body. Add the weapon system component. Before we touch the graph, look at the Details panel. Under Settings in the Details panel, set the weapon system data table we created. I'm setting the default weapon row name to Unarmed. This ensures the character initializes correctly without a weapon in hand. You can also see settings for health caps, ammo limits, and debug toggles. Keeping these variables in the component keeps your character's variable list clean and manageable. In the animation blueprint, we go to Class Settings and reparent it to ws_anim instance. This is a huge time saver. It instantly gives the anim BP access to all the weapon variables like is aiming and current weapon type. Go to the My Blueprint tab on the left, click the gear icon, and tick the Show Inherited Variables box to see the variables from the weapon system. Inside the anim graph, we'll use cached states to keep things tidy. Create a cached state of the main states. Right-click and get the cached state of your main states. Pull off that and get a layered blend per bone. By using a layered blend per bone, in Layered Blend per Bones Layer Setup, create a branch filters for bone name. I use spine_01 with a blend depth of 1. A blend poses by bool with the condition of is aiming to decide if you are aiming or idling. And finally, 2 blend poses by enums. Pull in the current weapon type for a get node and pull for blend poses by EWS_item type. This will give you pins for each of the weapons in the enum. We can tell Unreal exactly which stance to use based on the weapon held. You can see me duplicating these blocks, one for your idle equipped state and one for your aiming state. This ensures your character looks natural, whether they are hip firing or looking down a scope. Drag in each of your idle or relaxed poses for each weapon to the Connect Your Idle logic from the Blend Poses by Weapon Type connected to the false pin of Blend Poses by Bool. And repeat the step for the aiming poses that go to the true pin. Almost there. Head back to the character blueprint. Now for the inputs. We're using direct key calls to keep the logic easy to follow. When we press a key, we call the Select Weapon node. That index pin is what connects back to our data table slots. For the aiming logic, we use Set Aiming on the component. This doesn't just flip a switch, it tells the system to update the camera and the animation state simultaneously. For firing, notice we use Fire Weapon on pressed and Stop Firing on released. This allows the component to handle the fire rate logic internally. If it's an automatic weapon, it will loop until you let go. We're also adding the Perform Proximity check. Unlike a heavy line trace that runs every frame, this only checks for nearby weapons or items when you tell it to. It's efficient and clean. We add a Modify Health node to test by damaging the character's health to test the health packs. And a Use Consumable node to use the health pack to add health back to the player. We add a Cycle Fire mode for those weapons set to change fire mode. This will go through your modes, whether single, burst, or full auto. We'll also need a Reload node to show the character reloading montage when we run out of ammo and need a new clip. Now we need a mouse wheel up and mouse wheel down to cycle through the weapons we have to select the one we want to use. You can toggle the prediction spline on and off in your character's blueprint by adding the Toggle Prediction Spline node. The weapon spawner is incredibly versatile. We'll need to select our weapon system data table, enter the name of the weapon we want to place, making sure it matches exactly to its row in the data table, and select WS_pickup. We can now duplicate each pickup we want in the level, and after placing them where we want them, change each one to the weapon we want in that placement. For an arcade feel, we enable auto pickup, rotation, and respawning. For the pickups like ammo and health packs, we grab the BP_pickup, select the category, whether it is ammo, weapon, which we should be using the weapon spawner for, or consumable, basically the health pack. Choose if it should be used immediately if it is an auto pickup. If not, it will be treated as an interactable pickup, and if it should use physics or stay floating. But for an adventure or survival game, we turn those off and enable physics. Now the weapon will fall and rest naturally on the ground or furniture. When placing health packs or ammo, remember the system has built-in clamping. If your max health packs are set to 3, the system won't let you waste a pickup if your backpack is full. Let's see it in action. The assault rifle shows off the cycle fire modes: single, burst, and auto. The shotgun demonstrates that pellet spread we configured in the table. Watch the grenade launcher. That's the prediction spline helping us aim. And with the bow, notice the slight camera shake if you enabled it in the data table, and the overdraw bonus if you hold the shot while aiming. You can also turn off the debug lines and prediction splines in the Weapon System Component Details panel. Finally, notice the adventure-style pickups. They stay on the ground until we perform our proximity check to grab them. And there you have it, a professional, data-driven weapon framework that stays out of your character's way. Modular, efficient, and simple to expand. If this helped your project, hit that like button and subscribe for more systems as they come out. And as always, have fun.